In a world where global power is rapidly being redefined by resources, technology, and infrastructure, Africa holds the potential to become a unified strategic system. The Phoenix Strategic Plan proposes exactly this transformation, moving from fragmentation to a continental integrated model, functioning as a single organism. This plan is not just a geopolitical vision, but also a logical simulation conceptually implemented in C++, where the entire continent is modeled as a dynamic system of data, resources, and connections. The Phoenix Plan starts from a central idea: Africa must be treated as a single network, not as a collection of isolated states. Each region becomes a node in a complex system, and between these nodes flow continuous streams of resources, information, and energy. In this model, the economy is no longer fragmented, but functions as a continuous balancing mechanism. When one region produces a surplus, it is not locked in place, but automatically redistributed to areas with deficits. At the same time, shortages are detected in real time and compensated through optimized routes. In programming terms, this system is built on graph structures, where each node and connection is constantly evaluated. The algorithms do not operate statically, but dynamically, recalculating routes and priorities based on system-wide changes. Following the same logic, infrastructure becomes a unified network. Transport, logistics, and communication are no longer separate systems, but parts of the same interconnected architecture. A change in one region instantly affects the entire system, similar to a synchronized distributed model. This structure allows for rapid responses to blockages, delays, or imbalances. Instead of slow and isolated interventions, the system reacts automatically through internal recalibration, adjusting flows until stability is restored. Energy plays the role of the vital backbone of this system. Renewable sources are integrated into a shared continental network, where production and consumption are continuously balanced. When one area produces more than it consumes, energy is redirected to overloaded regions. When a sudden demand spike occurs, the system redistributes the load to prevent instability. In the C++ model, this process is simulated as a flow optimization algorithm, where every decision is calculated in relation to the entire system, not just a single region. The core of the Phoenix Plan is its logical engine. Everything is represented as a complex data structure, where each country is an object, each connection is a relationship, and each flow is a transfer function between nodes. The system runs continuous simulations to analyze growth scenarios, external pressure, or internal imbalance. These simulations are not merely theoretical, but logically functional. They allow testing how the entire system behaves before any real-world implementation. Based on the results, the algorithm adjusts resource distribution, transport routes, and infrastructure priorities, maintaining overall stability. Beyond this structure, the Phoenix Plan introduces a key principle: adaptability. The system is not fixed, but continuously evolving. Every local change triggers a chain reaction, and the system responds like a digital organism that corrects its own imbalances. This approach transforms the continent into a living network model, where decisions are driven by data, connections, and continuous feedback. The final outcome of the Phoenix Strategic Plan is a continent that functions as a single, interconnected, and self-regulating system. Not as a political alliance, but as a functional architecture based on logic, data, and continuous coordination. An Africa where decisions are not fragmented, but computed in real time. And at the center of this unified system, a code decide.